Hi students, greetings from BSH Department of Adishankara Institute of Engineering and Technology. Welcome to Keam entrance class. Here I am discussing trigonometry. You already know that trigonometry is the study of relation between the sides and angles of a right-angled triangle. The first topic in trigonometry is trigonometric ratios. There are 6 trigonometric ratios. There are sin theta, cos theta, tan theta, cosec theta, sec theta, and cot theta. You already know the definitions of these 6 trigonometric ratios. So I am skipping that. Next, trigonometric identities. There are 3 basic trigonometric identities. Sin square theta plus cos square theta equal to 1. Second one is sec square theta minus tan square theta equal to 1. Third one is cosec square theta minus cot square theta equal to 1. From the second equation, we can write the identity as 1 plus tan square theta equal to sec square theta. And from third equation, we can write 1 plus cot square theta equal to cosec square theta. Next, quadrant system. An entire plane is divided into 4 quadrants: first, second, third, and fourth. In the first quadrant, all the trigonometric ratios are positive. In the second quadrant, only sine and cosec are positive. In third quadrant, tan and cot are positive. In fourth quadrant, cos and sec are positive. To remember this, you already know the term all silver teacups. You already use that. Okay. Some of you have difficulty to remember the values of sine pi minus theta, cos pi plus theta, sine pi by 2 minus theta, etc. Here I am discussing a trick to remember that. First, denote the first quadrant as theta, or denote that quadrant values as 90 minus theta or 360 minus theta. Then second quadrant as 180 minus theta or pi by 2 plus theta. Third quadrant as pi plus theta or 3 pi by 2 minus theta. Fourth quadrant as 3 pi by 2 plus theta or 2 pi minus theta. The 6 trigonometric ratios sine, cos, tan, sec, cosec, cot, all trigonometric ratios are same if we write in multiples of pi. Example, sine pi plus theta is have no change sign. Sine pi plus theta, cos pi plus theta, etc. Then if we write in multiples of pi by 2, that is pi by 2, 3 pi by 2, etc., the sign changes to cos, tan changes to cot, cosec changes to sec. Next, consider an example, sec pi minus theta. Here, this is in the form of multiple of pi, so sec remains same, sec theta, and pi minus theta is in the second quadrant. In second quadrant, only sine and cosec are positive. So here the basic function is sec changes to minus sec. Then next one, sine 3 pi by 2 plus theta. Here it's in the form of multiple of 3 pi by 2 or multiple of pi by 2. If we write in multiples of pi by 2, sine changes to cos, and 3 pi by 2 plus theta is in the fourth quadrant. In fourth quadrant, cos and sec are positive. Here the basic function is sine, so becomes negative, minus cos theta. Next, sine pi by 2 minus theta, multiple of pi by 2, so sine changes to cos, and pi by 2 minus theta is in the first quadrant. In the first quadrant, all are positive, so plus cos theta. Next one is cos pi plus theta, multiple of pi, so cos remains same, cos theta, and pi plus theta is in the third quadrant. Third quadrant, only tan and cot are positive, so cos becomes negative, minus cos theta. Next one is tan pi by 2 minus theta, multiple of pi by 2, so tan changes to cot, and pi by 2 minus theta is in the first quadrant, so all are positive, so plus cot theta. Then next one is compound angles. Sin A plus B equal to sin A cos B plus cos A sin B. You remember sin is front to cos, sin is friendly, so sin have a mixing of cos, sin A cos B plus cos A sin B. And next one is sin A minus B. The sign here is minus, so in the expansion sin A cos B minus cos A sin B, same signs in both sides. Next, cos A plus B. Cos A plus B equal to cos A cos B minus sin A sin B. Cos is not friendly with the sin, so cos become friend with cos B. Cos A cos B minus sin A sin B. Cos A minus B equal to cos A cos B plus, here sign changes in both sides, cos A cos B plus sin A sin B. Next one is tan A plus B. Tan A plus B equal to tan A plus tan B by 1 minus tan A tan B. Same sign in the numerator and left side. In denominator the sign changes. Next, tan A minus B equal to tan A minus tan B by 1 plus tan A tan B. Next, factorization formula. Sin A plus sin B is equal to 2 sin A plus B by 2 cos A minus B by 2. Sin A minus sin B is equal to 2 cos A plus B by 2 sin A minus B by 2. Next, cos A plus cos B equal to 2 cos A plus B by 2 cos A minus B by 2. Last one, cos A minus cos B, not that, here minus 2 sin A plus B by 2 sin A minus B by 2. Next, defactorization formula. Next, let us do some problems. The first one, if sin 2 theta equal to cos 3 theta, where 0 less than theta less than pi by 2, then what is the value of sin theta? Four options are there. Option A, root 5 plus 1 by 4. Option B, root 5 minus 1 by 4. Option C, root 5 plus 1 by 16. And option D, root 5 minus 1 by 16. Here given that sin 2 theta equal to cos 3 theta. We can write cos 3 theta in terms of sin using the quadrant systems as sin pi by 2 minus 3 theta. Then second question, if tan theta equal to 1 by 2 and tan phi equal to 1 by 3, then what is the value of theta plus phi? Here we have, there are 4 options. Option A 0, B pi by 6, C pi by 4 and D pi by 2. Here we have to find the value of theta plus phi. So use the formula tan theta plus phi. Tan theta plus phi equal to tan theta plus tan phi by 1 minus tan theta into tan phi. Then tan theta and tan phi values are given. So substituting the values of tan theta and tan phi, we have 5 by 6 into 6 by 5, that is equal to 1. Tan theta plus phi equal to 1. So we can write theta plus phi equal to tan inverse 1. Already know the value of tan inverse 1, that is pi by 4. So the correct answer is option C, pi by 4. Next, third problem. What is the value of cos 46 into cos 47 into cos 48 into cos 49 into etc. cos 35, 135? The options are option A -1, option B 0, option C 1 and option D greater than 1. We have to find the multiple value of these terms. We know that this is a continuous terms, so cos 90 is in between the terms. We know that the value of cos 90 is 0. All the terms are multiplied, so multiplication with 0 is 0. So the final answer, correct answer is 0, option B 0. Then fourth one, if cos A equal to 3 by 4, then what is the value of sin A by 2 into sin 3A by 2? The options are A 5 by 8, B 5 by 16, C 5 by 24 and D 7 by 32. We have to find the value of sin A by 2 into sin 3A by 2, and this is of the form 2 sin A sin B. So using the formula 2 sin A sin B, we can find the value. 2 sin A sin B is equal to cos A minus B minus cos A plus B. Here a 2 is missing, so multiplying and dividing a 2 by the terms, 1 by 2 into 2 sin A by 2 into sin 3A by 2, that is equal to 1 by 2 into cos A by 2 minus cos 3A by 2 minus cos A by 2 plus 3A by 2. A by 2 minus 3A by 2, that is 2A by 2, that is A, and A by 2 plus 3A by 2 is 4A by 2, that is cos 2A. So 1 by 2 into cos A minus cos 2A, and cos 2A can be written as 2 cos square A minus 1, that is equal to 1 by 2 into cos A minus 2 cos square A plus 1, and substituting the values of cos A, we get the answer as 5 by 16. So the correct answer is option B, 5 by 16. The answers to the problems are given. Thank you and best of luck for you.